All right. Hello, everybody. Salam alaikum to my friends in the region. My name is Adam Szymanski. It's my great pleasure to welcome you here in my capacity as the president of KAPSARC. I'm delighted to see so many people joining us today to explore aspects of the circular carbon economy concept. KAPSARC engaged with leading international organizations to write a series of reports on carbon management that form the CCE guide. The cornerstone of the guide has been that each partner has full independence and control over the content of their reports. The CCE webinar series will explore key results of the studies that were produced. I'd like to offer a very warm welcome, re-welcome actually. This is Dolph's second presentation. Our guest today is Dr. Galen from IRENA, the International Renewable Energy Agency. Dolph will be discussing the role of bioenergy in the circular carbon economy. I'd like to say a little bit about KAPSARC. We are a non-government energy think tank located in Saudi Arabia. Our mission is to advance the understanding of energy, economics, and the environment, and act as a catalyst for dialogue on issues of importance to policymakers and the public. This year, the respected University of Pennsylvania think tank rated KAPSARC in the top quartile for energy think tanks globally. For the Saudi G20 presidency, KAPSARC was selected to co-lead the think tank engagement group called the T20 or Think 20. Our Vice President for Research, Dr. Fahad Al-Turki, was appointed the chair of the T20. Our work on the CCE guide that was coordinated by Eric Williams was extensively used by the G20 energy ministers, and the CCE framework was adopted at their September meeting. Now, just a little bit about the circular carbon economy, and Eric will be telling you more about this. Experts agree that the challenge of achieving our climate goals is best met by encouraging all options to manage greenhouse gas emissions. One of the organizing principles of what we call the circular economy is the 3 R's of reduce, reuse, and recycle. The circular carbon economy embraces each of these principles and adds a 4th R, remove. These 4 R's form a broad basis for carbon management. The CCE framework is an integrated and holistic approach to a more comprehensive, resilient, and climate-friendly energy system that supports and enables sustainable development. CCE encourages the broad development of technologies associated with managing carbon dioxide and other greenhouse gas emissions, and seeks practical solutions that foster economic well-being and improvements in the quality of life for everybody. Let me just quickly introduce Eric Williams. Eric is a senior research fellow at KAPSARC. He has over 20 years of experience as an energy and environmental economist focusing on energy and climate change policy, energy systems analysis, and climate change mitigation and adaptation options. Before joining KAPSARC, Eric worked as a utility commission economist and was a consultant for the OECD. So Eric, over to you.
Thank you, Adam. I'm just going to talk very briefly about circular carbon economy. And I find that it's often helpful to put circular carbon economy in comparison to circular economy, which a lot of people are familiar with. And as Adam mentioned, circular economy is based on the principles of the 3 R's, reduce, reuse, and recycle. And circular carbon economy adds a 4th R for remove. And so what is circular economy? It's really a framework for sustainable production and consumption. And circular carbon economy is a framework for climate mitigation that values all options. The scope of the circular economy is really focused on resource and material flows, whereas the scope of the circular carbon economy is energy and carbon flows. The goal of the circular economy is to minimize resource consumption and waste disposal. The goal of the circular carbon economy, on the other hand, is to manage greenhouse gas emissions, including CO2, toward a balance or net zero. Next slide. So this graph is just a very, very simplified, stylized version of circular carbon economy. And you can see at the center is the circular economy of material flows and products. What powers that circular economy is energy efficiency and energy supply in the form of hydrocarbons, nuclear renewables, and bioenergy. The circular carbon economy, as I mentioned before, is reduce, reuse, recycle, and remove. And the reduce elements are those that reduce the carbon that has to be managed in the first place, and those include energy efficiency, renewables, and nuclear. And then recycle, which is the subject of today's presentation by Dolph, it takes advantage of the natural carbon cycle in which photosynthesis draws carbon dioxide out of the atmosphere, natural sinks grow biomass, and then those are harvested to create bioenergy, which feeds back into the circular economy. You can also remove carbon from the system by capturing it and then storing it geologically. You can also capture it directly from the atmosphere and also store it geologically. And then finally, you can take carbon that you've captured and reuse it by creating chemical feedstocks or even fuels with CO2, and then feeding those products back into the circular economy. And so with that, I want to turn it back to Adam. Thank you. Adam, you're muted.
Thanks, Eric. For 2 decades now, Dr. Galen has worked in international organizations assisting countries to find common ground and exchange best practices to develop joint strategies. Dolph's work covers national, regional, and global level advice on renewables. For the last 10 years, Dolph has led the Innovation and Technology Center at IRENA. Dolph has advised IRENA members on diverse issues related to accelerating renewable energy deployment and the energy transition. He has a fellowship at the Colorado School of Mines out in Denver in the US, and he makes regular contributions to peer-reviewed papers, including scientific journals. He holds a PhD in engineering from Delft University of Technology. Dolph, we're delighted to have you back again today. So thank you very much. And please tell us about bioenergy.
Thank you very much, Adam. It's indeed a pleasure to be back. And thank you very much to Eric for the scene setting. Let me try to share my slides.
We can see the slides now, and now they've gone full screen. So you're in good shape.
Good. Thank you. Bioenergy is the only form of renewable carbon. So in a circular carbon economy context, that is a very important feature, and it's also the most widely deployed form of renewable energy technology today. It accounts for around 10% of all primary energy use worldwide. And we have a lot of experience in dealing with biomass as a commodity. On one hand, as in forestry, there's around 4 billion cubic meters of wood that is harvested and used every year. If you translate that into CO2, it's equivalent to about 3 gigatons of CO2 per year. So that's about 10% of global emissions, energy CO2 emissions. And in agriculture, it's for example, 2 gigatons of grains that are produced every year, which translates in around 4 gigatons of CO2. So there is experience in dealing with biomass at a gigaton scale, and it has high CO2 relevance. And there is significant potential to grow the use of biomass, bioenergy. So total bioenergy use, according to our estimates, can roughly double between now and 2050 to around 125 exajoules of primary biomass. Or if you also include traditional biomass, so that's the biomass which is used for cooking in developing countries, then there is a potential to roughly double the total amount of biomass. Now, that potential has been recognized already for some time, but the growth has been a bit lagging. And one of the factors there is cost. So the cost of bioenergy depends very much on the feedstock cost. And that's the economics there are a little bit different than for, say, solar PV. Because the more solar PV you install, the more learning effect you have in the manufacturing process, and the cheaper the solar PV becomes. But for the feedstock for bioenergy, you have a supply curve. So the more of that bioenergy feedstock you demand, you use, the higher the price. So you see exactly the opposite effect. The higher the demand, the higher the cost. Of course, you also have technology learning effects in bioenergy. For example, you see that there's a lot of attention focused on the use of residues, and to translate these residues, say, into advanced liquid biofuels. And so then you get access to a cheaper resource and a large resource base, but there the conversion costs are still a little bit on the high side. So there's more work needed. Talking about bioenergy in a COVID context, the liquid biofuels have clearly also suffered from the decline in oil price. So because they compete with oil and oil products in production cost, so you see that also now these low prices affect this industry. But longer term, we see a significant role not only for solid biomass, but also for liquid biofuels. We think that the demand for these fuels can grow about 4 to 5 fold between now and 2050, with about half of that being, let's say, conventional biofuels, mainly ethanol from corn and from sugar, and the other half being advanced biofuels from residues. And what these two colorful figures show you is, on the left, the structure of final energy consumption, so energy consumption in buildings, industry, and transport in 2017, which is our base year. And on the right side, it shows you the same graph, but for 2050, in a scenario that is compatible with well below 2 degrees, which we call the transforming energy scenario. And you see that the final energy demand is a little bit lower, which is already a great achievement, given that the economy grows roughly 2.5-fold during this period. And you see that the role of biomass changes. So at the moment, we have about 4% modern, 7% traditional biomass. In the total final energy use, we would move to 16% modern biomass in 2050. And as said, bioenergy is also quite unique because it's so versatile. So you can use it for power generation, you can use it for heating buildings. You can use it as a feedstock for biochemicals or biomaterials. You can use it as a feedstock for liquids, for road vehicles, but also for ships and for aviation. And because it has this carbon molecule, you can produce hydrocarbons this way, which are easy to handle. So in that sense, it has an advantage to compared to sources of renewable electricity, which you can use to produce hydrogen. But then you have still the challenge, how do you handle that hydrogen, which is a much more difficult molecule to handle, or you have to also react that with CO2. So because of the versatility of biomass, bioenergy on the supply side and on the demand side, it's in fact difficult to talk about bioenergy as a whole. You always have to look at what are we exactly talking about, and on the supply side, what are we exactly talking about on the demand side? And depending on that, you can make quite different, come to quite different conclusions regarding sustainability, regarding economics, regarding market potentials, etc. And so that versatility is a strength of bioenergy, but that diversity at the same time has a bit hampered the discussion around bioenergy. Because different stakeholders are talking about a different, let's say, mindset or mental map of what they mean by bioenergy. Now, looking a little bit into different sectors. So one sector where we see a significant potential for bioenergy is industry. We think that nearly a quarter of energy use in industry could be biomass by 2050. So that is a very significant role. And in fact, it's even a little bit more complex, because in industry, you have on one hand bioenergy, and on the other hand, you can also biomass use as feedstock, where it replaces oil and gas that are currently used as feedstocks. So, and applications there, for example, in the chemical and petrochemical industry, include dedicated bioplastics. For example, polylactic acid is one of these, but there are many different types. But also you can produce feedstocks, so building blocks from biomass. So, for example, it's possible to produce methanol from biomass, and then you can build a whole chemistry based on methanol. And such a chemistry already exists today in China, but there it's based on methanol from coal. But in principle, the whole pathway for a biomass methanol chemistry, petrochemistry, is in place. And also you can produce, for example, ethylene from ethanol from biomass. And then once you have ethylene, you can produce polyethylene and all other commodity chemicals. Now, the problem with these production routes is that they're roughly, at the moment, twice the cost of those based on oil and gas feedstock. So economics is the main challenge for this transition. And then we're again back to this issue of where do you get really cheap biomass feedstock. Another industry where there are interesting opportunities for biomass is the cement industry. The cement kiln is a very let's say, versatile, a very robust technology that can deal with also energy feedstocks of low quality. For example, you can use refuse-derived fuels, or you can use waste tires, etc. You can use wood construction waste in cement kilns. And even if there is some pollutants in the feedstock, in the cement kiln will filter these pollutants. So it's a very beneficial use even of lower quality bioenergy. And you can operate such cement kilns with 100% waste fuel or biomass fuel. Now, where it gets interesting is that a cement kiln also has a lot of CO2 emissions because of the process emissions, the calcination process. And to deal with these, you have to apply CO2 capture and storage. So if you combine the two, you use the biomass, but you apply also CCS, you get BECCS. You get biomass CCS. And that's interesting because that's an option that actually removes CO2 from the atmosphere. So first, the tree captures the CO2 from the atmosphere. You burn the biomass after use in a cement kiln, and then you store that CO2 underground. So the net effect is that you have removed CO2 from the atmosphere. And this cement kilns with CCS, it's something. Currently, there are two pilot projects in Europe, one in Norway and one in Belgium. And this is something that we think deserves more attention. So cement kilns is one option for BECCS, but of course there are also other options. There are some processes, you need a process which has sufficient size, and there are some processes of sufficient size where biomass is used. For example, in the sugar industry, so bagasse boilers, in pulp and paper mills, in ethanol production, and for example, waste incinerators as well, where a lot of kitchen waste is incinerated, which is in the end also biomass. So if you capture CO2 from these processes and store it underground, you have BECCS, and you're net removing CO2 from the atmosphere. And that will probably be needed longer term if we really aim for net zero CO2 emissions mid-century. So I already mentioned the liquid transportation fuels. We see a significant role there. And here in green, it shows how these biofuels fit with the overall use of energy in the transport sector. So we see up to 20% of transport final energy demand being liquid biofuels by 2050. And that is then in combination with a strong electrification in this sector, for example, for passenger cars, but also increasingly for commercial vehicles and trucks. Now, we think that the biofuels are especially important for aviation, for shipping, and for long-haul freight. And so moving into aviation, that's a hard to decarbonize sector because you need a fuel with a high energy density. You cannot work with batteries in a long-range airplane. And these high-density fuels can either be completely synthetic, that you start from hydrogen, react that with CO2 to make a synthetic fuel, or the use of biofuels. And we think that biofuels in this sector will play an important role. But of course, this is another example of a sector that has severely suffered and is still suffering from the COVID crisis. So that is pushing the developments here a little bit to the back burner at this moment. And there could be an important role for governments to step in to fill this void now. Now, shipping, especially ocean-going vessels, there are two options being discussed for that category at the moment. One is ammonia fuel, and the other one is methanol. And that methanol can be produced two ways, either, again, synthetic production or methanol from biomass gasification. And we think that there is a significant role for this biomethanol. But also, for example, you can think of the use of liquefied biomethane. So you produce biogas, separate the biogas CO2 out, what you're left with is a methane, biomethane, which is exactly the same methane that is used for production of LNG, which is an option which is currently being introduced in the shipping sector. So we see some interesting opportunities and some interest, in fact, also in the shipping sector. We have looked closely at methanol. We have a report coming out, an innovation outlook on methanol that we have developed together with the International Methanol Institute. And there we look at e-methanol, but also at biomethanol. So we think that biomethanol will play a role as a feedstock, but also will be used in shipping. And in fact, there are a number of projects for biomethanol production that are either in operation or that are under development. So the biomethanol production from biomethane is in operation. Also, the pulping cycle recently started in Sweden. The gasification projects, I think the one in Edmonton is in Canada is in operation. The one in Rotterdam is currently being developed. So interesting developments around biomethanol. So as I said in the beginning, we see a significant potential for bioenergy, and we think that bioenergy has a critical role in energy transition, but we see a bit of a paradox that its development is a bit lagging. Part of that is what I mentioned, the conceptions around biomass and bioenergy. Another one is that cost, and notably feedstock cost, are an issue that needs to be tackled. We issued we had a survey of CEOs of major advanced biofuels companies, and we issued a report on that about 1.5 years ago. And apart from these two factors, they also mentioned the need for credible long-term enabling policy frameworks as a key concern. So, because investments in these sectors are in the end investments for decades, and that's only happening if there is indeed a conviction that bioenergy will be part of a long-term transition solution, that there is a political will for that. So, key actions. Clearly, there is a role for policymakers to ensure that bioenergy is a key component of national energy policy. In that context, the nationally determined contributions to the Paris Agreement goals that need to be revised for the COP next year is a very important step. There is a need to consider the role of bioenergy longer term in the energy system. So if you do you apply the limited amount of biomass for power generation? Do you use it for the liquids? If you use it for liquids, is it for road vehicles? Is it for aviation? Is it for shipping? On all these points, you need to be very clear. It's critical to have clarity to allow the development of this sector. Then, of course, you need to make sure that the biomass feedstock is produced in a sustainable way, and certification systems are really critical for that. The final slide, so how to leverage synergies between bioenergy and the wider biomass sector. For example, the issue of biorefineries comes into play there. How you combine bioenergy with food production, with production of materials, with other forms of land use, and all these aspects need to be considered to find the right niche and the right business opportunity for bioenergy. So just looking at bioenergy from an energy perspective is probably not good enough to develop the full potential of this sector. I already mentioned biomass BECS, biomass with CCS, as an interesting opportunity, and bioplastics as another emerging solution, bioplastics and biochemicals. And so it's an area that where we will probably also see some trade, and where there is a significant potential also to exchange on best practices on all these aspects that I have mentioned before. So that concludes my remarks. Thank you.
Thanks very much, Dolf. We've had a few questions come in. One of the first ones that I answered on online was, will there be a recording available, and would the slides be available? And yes, they're all going to be on the cceguide.org website. So please check out the website. There's lots of very interesting material on there. Dolf, one of the questions was about no-till agriculture, and how are we doing in terms of soil management, regeneration through no-till or low-till plowing practices? Are you familiar with that?
Yeah, so that is an approach that was widely hailed a couple of years ago. My sense is a little bit, it has gone a bit silent. I haven't heard that much in recent years. One of the related topics which we've recently looked at was agroforestry in an African context. So where you have agriculture, but you plant also trees or shrubs in between. And if you pick the right ones that fix nitrogen from the air, in fact, it helps to fertilize the land. So you get higher agricultural yields, and at the same time, you have some biomass byproduct that you then also can use for energy purposes. So it's what I mentioned. You need to look at solutions that serve a number of purposes at once if you want to make this sector work.
Or solutions that work in the national context of countries where you're trying to help. I think that no-till and low-till agriculture has also been useful in soil erosion context, and that's a positive side effect that you would get from that. I think, Dolf, I did read a little bit about no-till agriculture, and there are some questions about how whether or not doing that is completely helpful, or it does have some side effects. But I think that generally speaking, it's seen as a positive. Another question was trees, forests release CO2 at night. What's the average volume of CO2 released? Is that anything? Let me just try that. That seemed pretty obscure. A quick internet search. Everybody's expert with Google. Dolph, maybe you could comment on this. Is the release of CO2 at night is about half of the CO2 that's absorbed during the day by photosynthesis. So trees, mangroves are still net carbon sinks as long as you're not burning the resultant products. So to the extent that those products have long lives, you're making progress. And there's also soil remediation effects associated with all of that too. One of the positives with mangroves, there are co-benefits. Mangroves in coastal areas help reduce erosion and can help deal with flooding and other coastal problems associated with that. So again, positive side effects.
And improve fisheries.
Eric, over to you for a question or two.
Thanks, Adam. So you mentioned bioenergy with CCS or BECCS and its importance. And I know that a number of global scenarios have identified BECCS as playing a potentially significant role in meeting future climate goals. It seems that you need, of course, two things for BECCS. You need good bio resources and you need access to CO2 storage. Are there any particular locations around the world that have both really good bioenergy resources and CO2 storage capacity?
So the biomass, to some extent, you always need to gather. And I'll give you one example what I mean by that. You had a former coal plant in the UK, Drax. That plant completely converted to biomass. It's a big plant. It's a 4 gigawatt plant, I think. And they import pellets. And the plant is on the North Sea coast. And the North Sea, of course, is one big potential storage reservoir. There's a significant potential for storage. So in such a location, you can think about BECCS. And there were similar plans in the Netherlands. But in the Netherlands, the discussion became one very much about, well, is the import of these pellets really sustainable? So technically, things are possible, but acceptance remains one of the main concerns. And then, I mean, other plants where such aggregation already happens for economic reasons are, for example, pulp mills, or I mentioned these bagasse boilers. So there you need to look a little bit what is the storage potential. I think in Scandinavia, in Sweden or Finland, it's not that good. But of course, there are plans to also ship CO2 from, for example, certain production sites in Norway, and then to store it in the North Sea again. So you could do the same from other sites. So, but all of that for the time being is still not at all widely deployed. And whether we will see deployment really at gigaton scale is also still to be seen.
And are there policies at national level or mechanisms that could be implemented at the international level that might facilitate this sort of deployment, especially if you're transporting CO2 from one country to another, or importing biomass pellets? I mean, what are the cooperative mechanisms that might facilitate this sort of cooperation to deploy this kind of complex solution?
Well, a CO2 price that is sufficiently high, of course, is a good starting point. But then indeed you need to be careful. A CO2 price on what exactly? If it's only on fossil CO2, but biomass is completely outside that system, you can already get funny effects. And is it only emissions to which a CO2 price is applied? Or if you have systems with negative emissions, would they then get a credit? That's another issue to be clarified. So it gets very complex with these biomass carbon flows, which are not treated the same way as fossil carbon flows.
And to your knowledge, have any policies tried to address those specific issues? I mean, the EU trading scheme, is there anything that tries to address bioenergy in that way?
Interesting question. I don't know whether, I mean, of course, right now, if you use bioenergy and you replace, say, coal, then you reduce emissions. So that then there is a credit. But if you would apply BECCS and then whether you get a credit for the storage, I don't know.
What Eric and Dolph, I wonder if that's something that could possibly considered under Article 6 when the COP meeting convenes at the end of next year in Glasgow. Dolph, there was an interesting question, and it may take a little thinking. It's how do you handle air pollution such as NOx and particulate matter combustion? One of the things, and I was kind of curious about whether the question was related to, there are some biofuels, non-commercial biofuels being used now for cooking purposes, for example, and there's a big effort underway globally to replace these these kind of old fashioned biofuels for cooking with more modern sources, solar electric heaters, or even propane or butane stoves to enable cleaner indoor atmosphere, particularly for women and children who are affected more, I think, because they tend to stay home in traditional societies and have these not clean cooking fuels. Is there anything that you know of that's being done to in the biofuel area to deal with things like NOx and particulate matter?
Well, so for the traditional biomass, I would say the main effort at the moment is related to clean cooking stoves.
Right, replacing those fuels.
Replacing this, yeah.
Right.
Also, there has been some effort, for example, to introduce biogas or say bioethanol as a cooking fuel with various success. I mean, it worked well in China, but the biogas uptake elsewhere, a little bit in India, but elsewhere is not that great. Africa, for example, not that great. So there is indeed still a significant traditional biofuel issue. Yeah, but that is something that not only from an air pollution and health aspect deserves attention, but also from a greenhouse gas aspect, because it's also a significant source of methane emissions. The problem of pollution from bioenergy is not only, let's say, in the traditional biomass, but for example, also biomass stoves in developed countries for heating. It is possible to have clean burning bioenergy stoves, but they need to be operated well, which is often more of a challenge. So that's why we think that the main role of bioenergy will probably be in larger systems that are easier to manage.
Right. One of the earlier questions about no-till farming, the individual came back and was actually left some helpful links to articles in Nature magazine and a few other places on the benefits associated with land use activities that can be helpful. And I think you already mentioned other agricultural practices, Dolph, that would probably be pretty useful in that area. There was a question about hydrogen versus biofuels. Which do you think is going to take off earlier? Which has the best head start?
In what market?
Yeah, that's probably the right follow-up question to ask. And I think that in hydrogen clearly is going to work in those places that have access to either natural gas or oil for blue hydrogen, or to some form of renewable electricity, wind, solar, or green hydrogen, and conversion to ammonia. And that's going to limit that geography. And I think I see your point, Dolph, that biomass might take off in those places that have agricultural opportunities, but might not have the denser hydrocarbon fuels. Any thoughts on technological breakthroughs in the biofuel area? I do remember that there was a lot of effort being made to find improved ways of converting biomass into ethanol and methanol, advanced technology. Where do we stand on that?
So I would say quite a lot of development at the moment around biomethanol. But advanced technologies, I mean, basically it is either this biomethane route, and then you are back into steam methane reforming, or it's the gasification of biomass, which is also already for quite some time at least developed and to some extent deployed. On the advanced biofuels, I see recently there is some work on bioaviation fuels, advanced bioaviation fuels. But again, that's largely driven by policy. For example, Norway has a mandatory share of liquid biofuels for aviation, and that will go up over time. And that then results in a demand that people say, okay, then I can invest there and build a factory. So policy is really still very important in this sector.
The water, and this is actually an interesting question, and you alluded to it earlier. What kind of accounting and key performance indicators do we need to come up with to accurately account for the sequestration value of biofuels?
The sequestration value of
Yeah, in other words, how do you compare biofuels with direct air capture and putting something, it's like, it might be a well to wheels question or full life cycle, who is working on the standards that we need to accurately compare the CO2 and greenhouse gas full cycle benefits associated with different fuels?
Well, I think life cycle analysis is certainly plays a key role as an analysis tool there. Of course, there are many studies out there. They're not always consistent in their findings. So one question is, are we just talking CO2? Are we talking all greenhouse gases? To what extent are, let's say, which scope of the system is really considered in the analysis? For trees, for forests, the question is always, what is exactly your starting point? An empty piece of land or a standing forest? And are we talking 100-year cycle, or are we talking 500 years, and then of course, if we talk, say, in a Brazilian context, the question is always, well, okay, maybe not on the specific field where you grow the sugarcane, you have a CO2 problem, but maybe you have moved the cow that was there before, and for that you have cut down the rainforest. It gets very complicated.
Yeah, there was actually one question about the problem that we had with palm oil resulting in deforestation to grow palm oil and unintended consequences. I certainly don't think that we would want to pick on biofuels as being the only energy source that has unintended consequences. We see that across the board. My own experience over the years is there's no perfect fuel, and one has to be very careful and try to take into account as many things as possible. One thing for sure I believe in is we need lots of effort to accelerate technology across all of the possible solutions, and that includes bioenergy as well as other forms. I think there are probably, as the one commentator said, there's probably a lot of opportunities in the agricultural area. Biojet fuel, that's something that's come up in terms of, is there some way that we can fly aircraft and still deal in some way with the greenhouse gas emissions? Any thoughts there, Dolph?
Yeah, so in the field of transport, we see aviation really as a key area of application. Yeah.
Is there, how are biofuels shaping up in terms of financial support? I mean, I think that the COVID crisis has created financing problems for everybody. I mean, even shale oil producers, for example. Efforts to push stimulus packages towards green solutions. Are you seeing any activity there?
For bioenergy at the moment, not that much.
Right.
For example, a country which still has a very bioenergy focused policy at the moment is Indonesia, and also in the liquids. In Brazil, of course, they have the targets for ethanol in the petrol. So these type of policies are not that much affected by the lower prices. Of course, the producers would like to see much higher prices, but,
Right.
but in the end, if you have a policy like that, it doesn't affect the volume that much.
Yeah, one of the points that might come up there is the Biden energy policy papers that were part of the campaign suggested some possibility of moving back towards biofuels and ethanol, for example. Dolph, we're coming up, we're 1 minute away from the top of the hour. I'd like to take this opportunity to thank you and the International Renewable Energy Agency very much for your efforts on renewables, non-bio renewables, wind, solar, and so on, and as well as today's topic, bioenergy. Eric and I have been absolutely delighted to have had the opportunity to work with you and IRENA on these issues. We think it's an important part of the circular carbon economy, and we look forward to working with you in the future on these topics. So Adam Szymanski at KAPSARC, again, thank you, Dolph and Eric, and all of our listeners out there today. We'll try to collect whatever questions got left over, and Eric has been working on a frequently asked question portion of the CCE guide.org website. And if we didn't get to your question today, please have a look at the website and maybe you'll find the answer in the frequently asked questions. So Dolph and Eric, thank you very much, and goodbye to everybody. Take care.
Thank you. Bye-bye.
Right.